Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Comes to the Mystery of Molecules. Today's topic of discussion is alkene versus alkyne based on their chemical reactivity. More specifically, if I ask which one is more reactive between alkene and alkyne, we shall try to understand the answer of this question logically. Before going to details, one MCQ, that is 1-butene, 6-butene, trans-2-butene. Among these three, which have the highest heat of hydrogenation? So 4 options are provided. I request you please pause the video and write your answer in the comment box, and definitely end of this discussion you will get the right answer. Let's start. If you look at the alkene and alkyne, their orbital, this is the simple, this is a 1 double bond, and this is the orbital image, means this 2 p orbital do parallel overlap and produce this alkene, you can say. Means actually this is the phase is plus and minus, so this is the molecular orbital looks of this alkene. Now similar way alkyne, in this case these carbons are sp hybridized, so 2 p orbitals do parallel overlap and they produce 2 pi bonds. And you can see here, see this black versus this red have angle 90 degree, so there are 2 pi bonds, and in between these two MO the angle is 90 degree. So from this thing we can say that this alkyne is more electron rich, because this pi bonds are this, in case of pi bond the electron density is not in between the two atoms, they are above and below the atoms, and since there are 2 pi bonds in case of alkyne, so the electron density over this carbon atom, means the pi bond is more, 2 pi bonds are there. So based on this understanding, we can say actually the deciding factor will be electronegativity and hybridization of the atom. We shall explain based on this, electron clouds and number of pi bond, and stability of the intermediate. Now see, if you look at based on the electron cloud and pi bond, alkyne has more electron cloud. Consequently, it is expected that it is more interested to donate its electron pair. So from this thing we can expect that alkene should be more reactive, but this is not the complete description. There are other 2 factors which will say something else. Now when a electrophile or electron deficient species react with alkene, what happens? This is electron deficient, so if it is electron deficient, it will try to react with electron rich species, and this pi bond is actually more electron rich because the electron density is not in between the 2 nucleus, it is above and below. So consequently it will react and it will produce this addition complex. See, initially these 2 carbon atoms were sp2 hybridized. After this reaction you can think that carbon became sp3 hybridized. We know sp2 hybridized means 120 degree bond angle, and from sp3 means 109 degree. So in this case reduction of bond angle occurs, and ultimately through reaction it produces this carbocation, and in this case this carbocation one is sp2 hybridized. And by the way, this carbocation can have some stability by hyperconjugation using the hydrogen in the adjacent atoms. So this is the overall thing. Now if we look at the case of alkyne, similarly it will react with this electrophile and produce this 3-member ring, but the interesting thing is that this carbon is sp2 hybridized, because the initial one was sp hybridized. Since it is sp2 hybridized, so bond angle is expected to 120 degree. Okay, because, and another thing, there is one double bond, so it's a 3-member ring, 1 double bond. It's relatively more strained molecule, so you can say this intermediate is relatively less stable. And ultimately after this, what is produced? So this bond is opens and produces this carbocation, and see this positive charge is in the sp2 hybridized orbital, and these do not have any significant stability. And we know that this carbocation, if it want to have stability, it is not able to get that stability like this one for alkene. So from this we can say that for this electronegativity and hybridization point of view, if we think, and the stability of intermediate, alkene is more reactive because the intermediates are relatively more stable. So from these understanding we can say that the alkene means 1 pi bond is more reactive compared to alkyne, which is having 2 pi bonds. So now, by the way, one question may come that, sir, in one reaction we have seen, means the linear catalyst, where the alkene could be converted, means this alkyne could be converted into alkene using some catalyst. If this is more reactive, if the alkene is more reactive, then how this intermediate could be isolated? Student, remember that how the reaction happened. Palladium, hydrogen, calcium carbonate and quinoline-sulfur, means this quinoline-sulfur is catalyst poison. So in presence of catalyst poison only we were able to get this alkene. Otherwise, if you do the hydrogenation reaction on this alkyne moiety, it will ultimately end up in alkane. So that was an exceptional case, so don't be misguided by that explanation. Now let's come to our MCQ. So in between 1,2-butene, 6,2-butene and trans-2-butene, which have the highest heat of hydrogenation? What is heat of hydrogenation? The heat released during the process of hydrogenation. So after hydrogenation, these alkenes are converted into alkane, and in that process heat hydrogenation released. Now let's draw the structure, then picture will be a little easier. This is trans-2-butene, this is 6,2-butene, this is 1-butene. We know that more substituted alkenes are more stable. So from this understanding, we can consider this 1-butene is relatively less stable. Student, please don't say the word it's unstable. This is relatively less stable compared to the more substituted one. So this relative word is very important here. Now another thing, in this case, so this is least stable. Now if I compare this trans versus 6,2-butene, which is more stable? Obviously trans. So now this thing you need to keep in mind. Now please check the explanation. This is the energy, means this, in this case this is the energy and this side is the reaction coordinate RC. So what happens? So here all the alkenes. Now based on previous discussion, which alkene is least stable? So this 2-butene, and in between second is cis1. And what about the third one? The third one is actually the trans one, means the trans one is most stable. Now here final product is same, butane. So the difference means you can consider this is the difference of this cis-2-butene. This is the difference, means this H. Now this is the difference, means A delta H. For example, you can see cis, and the third one, this is this one, this is delta H trans. Now if you look at from this delta H is greater than delta HC, means cis greater than delta H trans. So from this case we can say that the heat of hydrogenation, means the heat released during this hydrogenation process, is maximum for this 2-butene, means unsubstituted. So from this discussion we can say in which case have the highest heat of hydrogenation? Obviously for 1-butene. So answer is 1-butene. I guess you have understand the question now. So this is the end of the discussion. Thanks for watching. If you really enjoy my content, please help my channel, and I have a request, you please visit my another YouTube channel, Climate and Chemistry, where I upload global warming and climate change related videos. See you in my next video. Bye bye.